Imagine a future where treating obesity doesn't mean surgery, liposuction, or even killing fat cells, but instead reprogramming them into something healthier and more efficient. At Columbia University, researchers have developed a nanomaterial called P-G3, short for polyamidoamine generation 3, that may change the way we think about fat forever. Unlike current fat-melting injections or surgical approaches, P-G3 doesn't destroy fat cells. Instead, it targets the negatively charged environment of fat tissue, especially the visceral fat around organs and the subcutaneous fat under the skin, and uses its positive charge to home in on those areas with incredible precision. Once inside, it shuts off the machinery that allows fat cells to swell and store excess lipids, while leaving the cells alive and functioning. In other words, the fat cells stay fat cells, but they lose the ability to expand like they normally would in obesity. In preclinical studies on obese mice, injections of P-G3 reduced dangerous visceral fat, boosted energy expenditure, prevented weight gain, and even improved overall metabolic health. In another set of experiments, P-G3 alleviated chronic inflammation and reshaped fat tissue in a healthier way. This makes it very different from destructive approaches. Here the fat tissue is remodeled, not removed, and continues to function in a metabolically active, athlete-like way. So, is it available now? Not yet. P-G3 is still in the preclinical phase, meaning it's been tested in animal models but not yet in humans. The Columbia team has patents pending and is actively working on refining the material for safety, efficacy, and potential use in clinical trials. That process could take years, but the implications are huge. If successful, P-G3 could offer a non-invasive therapy for obesity and metabolic disorders, reducing fat in specific areas while also transforming how that fat behaves at the cellular level. Of course, with any experimental treatment, questions remain about long-term safety, potential side effects, and how well this will translate to humans. But the early results are exciting and point toward a new generation of fat therapies, ones that don't just remove fat, but reprogram it.